National Electrical Code Section 250.32 exception addresses the grounding requirements for separate buildings or structures supplied by a single branch circuit or feeder. The general rule requires a grounding electrode system at each separate building or structure. However, the exception provides an allowance under specific conditions. The question is whether a multi-wire branch circuit with a grounding conductor qualifies under this exception. The answer is yes, a multi-wire branch circuit with a grounding conductor can qualify under the exception 250.32 of the National Electrical Code, specifically the 2008 edition. This is because the exception focuses on the presence of an equipment grounding conductor run with the supply conductors to the separate building or structure. A multi-wire branch circuit inherently includes a neutral conductor and, when installed correctly, an equipment grounding conductor. To fully understand this exception, let's delve into the key aspects of NEC Section 250.32 and its implications. The primary requirement of Section 250.32 is that for separate buildings or structures supplied by a feeder or branch circuit, a grounding electrode system must be established at each building or structure. This grounding electrode system typically consists of items like ground rods, ground rings, or connections to the building steel. The purpose of this requirement is to ensure a low impedance path to ground for fault currents, thereby minimizing the risk of electrical shock and facilitating the operation of overcurrent protective devices. The exception to Section 250.32 allows for the omission of a grounding electrode system at the separate building or structure under specific conditions. These conditions are primarily aimed at ensuring that an effective ground fault current path exists back to the source of the power supply. Firstly, the circuit supplying the separate building or structure must be a single branch circuit or feeder. Secondly, the circuit must include an equipment grounding conductor run with the supply conductors. Thirdly, there must be no metallic paths between the separate building or structure and the source of supply. This eliminates the possibility of circulating ground currents or differences in ground potential. Now, let's consider the multi-wire branch circuit in this context. A multi-wire branch circuit consists of two or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, and which is connected to the neutral or grounded conductor of the circuit. Multi-wire branch circuits are commonly used to provide multiple 120-volt circuits from a 240-volt source, or to provide both 120 volts and 208-volt circuits from a 208-volt source, or to provide both 120 volts and 277 volts from a 480-volt source. The key element here is the presence of an equipment grounding conductor. The equipment grounding conductor is connected to the grounding terminals of all receptacles, equipment, and enclosures served by the circuit. It provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protective devices to trip and clear the fault. Since a multi-wire branch circuit, by definition and proper installation practices, includes an equipment grounding conductor run with the supply conductors, it satisfies one of the key requirements of the exception 250.32. This means that if the other conditions of the exception are met, specifically the absence of metallic paths between the buildings, a grounding electrode system is not required at the separate building or structure. It is crucial to emphasize that the equipment grounding conductor must be properly sized and installed in accordance with the National Electrical Code requirements. This includes ensuring that the conductor is adequately protected from physical damage and that all connections are made securely. The size of the equipment grounding conductor is determined by NEC Table 250.122, which bases the size and the rating of the overcurrent protective device protecting the circuit. Furthermore, it's important to verify that there are no metallic paths between the separate building or structure and the main building. This includes metallic water pipes, gas pipes, or any other conductive elements that could create a parallel path for ground currents. If such metallic paths exist, the exception 250.32 cannot be applied, and a grounding electrode system must be installed at the separate building or structure. In summary, a multi-wire branch circuit with an equipment grounding conductor can qualify under the exception 250.32 of the NEC 2008, provided that all the conditions of the exception are met. This includes the presence of a properly sized and installed equipment grounding conductor, the absence of metallic path between the buildings, and the supply originating from a single branch circuit or feeder. It is always recommended to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and standards. Proper grounding is essential for electrical safety, and it's crucial to understand the requirements and limitations of the National Electrical Code. Failing to properly ground electrical systems can lead to dangerous conditions, including electrical shock, fire hazards, and equipment damage. Therefore, it is vital to adhere to the NEC guidelines and to seek expert advice when necessary. The exception 250.32 is designed to provide flexibility in certain situations, but it should only be applied when all the conditions are met and when the safety of the electrical system is not compromised. Understanding the specific requirements of the NEC and applying them correctly is paramount for ensuring electrical safety and compliance.